Hi, how are you? In this video, we are going to see the definition of function. This is the second point of the unit functions. Okay, to see the definition, let's make two sets of numbers. The first set is called x, and the second set is called y. In the first set, we find different numbers. -2, 1, 0, 5, 6, random numbers, okay, because this is an example. In the second set of numbers, we're going to find also numbers 1, 0, 3, 4. Some numbers are equal, other numbers are different from the first set. A function relates each number from the first set to one single number to the second set. So it means that we have a relationship between -2 or from -2 to 1. So from -2, we cannot make a different connection. This is not possible in a function. In a function, we have only one relationship from -2 to 1. From 1, we are going to make another relationship, and this relationship can go to 1 because in the second set, one number can have different relationships. But from the first set, each number has only one relationship. So from 0, there is one relationship, for example, to 4, from 5 to 0, for example, and from 6 to 0 again, for example. The first set is called domain. The second set is called codomain. And the real numbers, the actual numbers in the second set that have a relationship, this set of numbers is called range. Cool. So this is a good way to see a function. But in mathematics, we are going to see functions in 3 different ways. So let's see these 3 types. The first way is as a formula. A formula has 2 different parts. The left side of the formula that we can represent in functions as the letter y, or also with the letter f of x. Okay, f means function, and x is the letter or variable that we are going to write in the right side. If instead of x we put a different letter in the right side, I have to write that letter. So if I have x in the right side, I'm going to have a formula with the letter x, for example, 3x. This is a formula, and this formula, 3x, is going to produce an output, where we call this in English output, and this output is going to be a number in mathematics. So for example, if in the x I'm going to put the number 4, I will have 3 times 4. Okay, remember that the f means function, only means function. And what I write here, the 4 in this case, x equals 4, is the number that I'm going to put in the formula. This operation is going to produce a number, 12. So from the first set, if I write the first set, from the 4 goes one relationship to the second set. From the 4 goes has a relationship to 12. That is the output. This is the result of this operation 3 times 4. If I put a different number in, for example 5 in the first set, this is going to produce another number. 3 times 5 is 15. Okay, so 15. From 5 we have a relationship to 15. So a formula represents also a function. Let's see another way to see a function with an ordered pair of numbers. If we take this pair of numbers, 4 and 12, we have 4 in first place, comma, the output, 12, the solution of the operation. This is a pair of numbers. 4 represents the x, 12 represents the y. And I cannot change the order. Always the first number represents the x and the second the 12. I can do the same with the second pair of numbers, the 5 and the 15. The first number is the x and the second is the y. So for that reason, we call this an ordered pair of number. Order because we cannot change the order, and pair because we have two numbers. Good. I forgot telling you that in a formula, if I write a formula, I'm going to write the formula here. The y is a letter, okay? It's called dependent variable. And the x, another letter, is called independent variable. And this is because in the independent variable, this is the variable, the set of numbers where I put numbers. I can put any number here in the x. As you see, the 5 and the 4, it has or doesn't have any logic. I have invented the numbers. Why? Because I can put any number in the x. For that reason, it has the name of independent variable. The dependent variable depends on the number that you put in the x. For example, if I put a 5 and this number produces the 15, this is 15 because I put 5. If I put a different number, 4, this operation produces a different number, a different solution. So the y is called dependent variable because it depends on the number that you put in the independent variable. Okay, good. We continue with the ordered pair of numbers. So this is also a function. What it's not a function is to repeat the x, and for the y, if I write a different number from the 12, a different, for example, 15, okay, this is not a function because the 4 is repeated. The 4 is twice. So from the 4 cannot go to the 15 because we saw at the beginning of the video that a number in the first set cannot have two relationships. So that's not possible. So only one relationship, and this is not possible. The 4 is ones, and the 4 has only one relationship. Okay. Well, so we're going to make a coordinate plane. And we are going to represent the two coordinates that we have up here, because this pair of numbers are also coordinates. So, well, I'm going to make this quickly. So the 412 could be right here, for example. And the 515, the second one, could be right here. Okay, kind of. The 515. So this representation is also a function. Okay. Well, I suppose that you remember from the first video that the horizontal line is the x-axis and the vertical one is the y-axis. Okay, so as I said before, these 2 points also represent a graph. If, for example, 4 is for example, x represents the age and y represents the height, as an example, these two variables can have decimal numbers. Okay, we can take decimal numbers. So in that case, the representation can have a line between these 2 points because we can take also decimal numbers. So we make a straight line between these 2 points. If we cannot take decimal numbers, we don't join both points with a line. Okay. Okay, so that's everything. Thank you very much.